Hello, everyone, and welcome. This is Who Needs ChatGPT Rock-Solid AI Pipelines with Hugging Face and Kedro. My name is Juan, Cano, and I'm going to talk to you a little bit about how Kedro can be used to scale AI pipelines. So first of all, this is what we're going to cover today. So I'm going to give a little bit of context on the differences between open models and commercial ones so that we can set the stage. We're going to describe what's the problem that we are trying to solve with Kedro, and we'll tell you a little bit about the project itself. And then I'm going to go to the demo part, show you around one use case that I made combining Kedro and Hugging Face pre-trained models. And I'm going to close with some conclusions. First, I introduce myself. My name is Juan Cano. I am currently a product manager at Quantum Black, AI by McKinsey. And I'm originally an aerospace engineer, but I taught myself how to code in Python, and I've been in love with the open source community ever since. So I'm a big advocate of open source tech communities, and especially the use of Python in science and data. And I'm on my journey to become a Kedro expert, so I hope that you can join me. First of all, needless to say that despite the catchy title of the presentation, we live in the golden age of commercial AI. So it's never been easier to interact with AI-powered apps and products. This is a screenshot from the recent announcements from OpenAI introducing the different flavors of GPT. And there are, of course, other companies that are running to provide similar services. But again, these commercial entities, they are providing us with an API. So it's not always clear what's inside the black box, or if we have any control in case we want to fine-tune some models and so on. So what if we want to use some open models instead? And this is where Hugging Face comes in. So Hugging Face is probably the largest and biggest marketplace for open, pre-trained artificial intelligence models. And I want to remark that open in this context is still up to debate. So the open source initiative, which are the guardians of the open source definition, are still debating what open source specifically should mean in the context of AI. Should we focus only in the code, or see also the weights of the model? Should we have disclosure of what's the architecture, and what was the training data, and so on? But for the context of this discussion, let's settle on calling open anything that we can download to our computer and run with little to no restriction. And in that sense, Hugging Face gives us more than 400,000 models that we can use. And the interesting thing is that it has lots of useful categorizations. So on one hand, you have computer vision models for different tasks, so image classification, object detection, and so on. Then, of course, you have natural language processing models, giving things like text classification, question answering, summarization, and so on. And you have multimodal models as well that can deal with text and audio or other forms of media simultaneously. And it's so interesting that these models are specific for a given task, because it helps us combine these models and come up with some sort of system that can do a very complex thing. But as always, with great power comes great responsibility. So using these open systems requires that you take responsibility of hosting them, managing them. You will have to serve these models from your infrastructure. Some of those are really heavy and require lots of computational resources, even for inference. So yes, using pre-trained models is worth the effort, but it requires some care. And in the end, this is all very similar to the typical problems that we've been hearing in general when deploying machine learning to production, right? Things like everybody works in different ways, or different people have different levels of exposure to good software engineering practices, or there's different code quality standards. So these have been quotes that we've been collecting from users and clients, and the story repeats itself, and it's even more complicated these days with the advent of more complex models. So long story short, picking your AI models is only the beginning of the journey, and you will have to do lots of different things to keep these systems running in a reliable way. So this is where Kedro comes in. So Kedro is an open source Python toolbox that applies good software engineering principles to data science code, with the idea of making it easy to transition from prototypes and experiments to production. It reduces the time spent rewriting data science experiments. It encourages harmonious team collaboration and improves productivity. And it also upskills all collaborators on how to apply these software engineering principles to data science code. It was created internally at McKinsey in 2017 and has been open source since 2019, so for 4 years now. And at the end of 2021, we donated it to the Linux Foundation AI and Data Initiative. So it is now a multi-stakeholder project that is developed by different entities. It has more than 9,000 GitHub stars and currently counts more than 400,000 monthly downloads. So it's a moderately successful open source project already. And only in 2022 alone, our telemetry says that there were more than 15 million pipeline runs. On the right, you have some of the companies that have adopted Kedro, and some of them are McKinsey clients, but many others are not, thanks to the open source nature of the project. So this is essentially how a Kedro pipeline looks like. So on the left, you have a visual representation of the pipeline. There are essentially two kinds of nodes. You either have datasets, which represents any connection to some file on disk or an object storage or a database, anything that performs all sorts of input and output operations. Or you can also have nodes, which are Python functions that are pure, therefore they don't run any sort of I/O, and they take the objects directly in memory as given from the datasets, and optionally they return some other objects that will become other datasets. The process continues from the beginning to the end until all the nodes have run and all the datasets have been produced. In the center, you have the catalog YAML file, which is our way of declaring where the datasets live and what sort of libraries we're going to use to read them. So in this example here, which is taken from our documentation, you can see that we're using CSV files, Excel files, Parquet files, and there's many other datasets that you can use. Each of these types are Kedro datasets, classes, and you can specify what's the file path. This can be a path on disk or in some remote location, thanks to FSSpec. And there are some extra arguments that you can specify. For example, if you want to version a specific dataset so that every time the pipeline runs produces a different one, you can specify version equals true. And then on the right, you have the Python definition of the pipeline. So a pipeline essentially is going to be a list of nodes. Every node is a very lightweight wrapper over a Python function, and it declares what are going to be the input datasets and which ones are going to be the output datasets. So essentially, Kedro will then connect all the nodes with one another, depending on what are the inputs and outputs, in a way that the pipeline runs exactly in the order that it needs to run. And this is basically the concept of nodes and pipelines in Kedro, but it gives you much more. So Kedro allows you to start a project with a standardized project template. This is inspired by cookie cutter data science, and we have been evolving it a lot over the years. There's also the data catalog layer that I just mentioned before. So essentially a declarative abstraction layer that helps us specify where the I/O is going to happen. Then nodes of pipelines that are the ones that perform all the computation. There's some experiment tracking functionalities as well, either with Kedro Viz, one of the plugins in the Kedro ecosystem, or through its integration with Kedro MLflow. More on that in a moment. All the execution of Kedro pipelines can be extended through the use of hooks. We're using the plugin framework, which is in use by the PyTest ecosystem, so it's battle tested. And there are several hook points that you can use. So for example, before and after the dataset is loaded, before and after a node is executed, and so on and so forth. This enables the community to extend Kedro in different ways, for example, by adding more logging functionality or connecting Kedro with other systems. So in summary, Kedro goes all the way from ingesting your raw data to training and validating the model. And then we encourage users to choose a deploying method of their liking. And in that sense, Kedro has integrations with different open source orchestrators, such as Airflow, Argo, Dask, if you consider Dask an orchestrator, Kubeflow, Prefect, and also lots of commercial MLOps platforms. All the Azure stack, Amazon Web Services as well, Databricks, Iwatio, which is a recent acquisition by McKinsey, Snowflake, and Vertex AI by Google. So we usually say that Kedro is a write once, deploy everywhere framework. Long story short, Kedro can be considered a data science development framework, a machine learning engineering framework, a pipeline framework, but it's not attached to a specific orchestrator or way of running your pipelines. And in that sense, it's orchestrator and platform agnostic. This means that Kedro doesn't aim to be a full stack MLOps solution or an orchestrator or a replacement for your data infrastructure. You will be authoring your pipelines in Kedro and then choosing where do you want to deploy them. If you want to get started with Kedro, there's a few touch points that I want to share with you. So in our blog, we're writing technical blog posts about recent news and developments that we've been working on in the team, plugins that the community has published, how to migrate your project, and lots of different things. There's a demo site as well in which you can interact with Kedro Viz and see how it looks like for an example project. All our documentation is online, so you can check it out and read it for yourself. And finally, if you want to join our community, we have a very active Slack workspace in which people ask any questions they might have. They share knowledge with others, share views about plugins and cool things they have done with Kedro. And so we will be very happy for you to join us there. And so after this introduction, without further ado, it's time for a little demo. So first of all, I'm going to explain where the idea for this project comes from. When I was preparing this talk, I saw a post on Mastodon by Luis Villa, who is currently one of the co-founders of Tidelift, former director of Wikimedia, and big open source advocate that I'm following. And he was wondering if there could be a system that could grab his posts on Mastodon regularly, then archive them, and use some sort of LLM to summarize them and publish that on his blog as some sort of summary. And I thought this could be a super interesting idea. And so I asked him if I could use his content, and he said yes. So everything I'm going to do now is with his consent in good Fediverse fashion. And I encourage you to do the same if you are harvesting someone else's data. But you can do this with your own posts as well. So essentially, this is the repository of the materials that I'm going to use for the demo. So this is a Kedro project that I upgraded for Kedro 0.19, which was released yesterday. And essentially, this is the architecture that we're going to follow. So the Mastodon content will come from the API. I already ingested that in an open source lakehouse that I'm deploying on my own computer. So this is using MinIO and the Delta formats that will give me some nice capabilities. all that ingestion pipeline was created by Kedro. And then on the data, after it's already ingested, I'm going to perform some transformations and then create some reporting pipeline that is going to use some some Hugging Face pre-trained models to come up with a summary for the latest content. So bear in mind that this is a simple prototype, simple enough that it can be shown in a demo, but hopefully it will give you a nice idea of what can be done. This is an architecture of the project that we're going to use. So essentially you see that there's the ETL pipeline on top that is going to extract the statuses from the Mastodon API, and then it's going to perform some transformation on them. I'm going to talk a little bit about this in a moment. And then once I have my status stable, I'm going to do some data cleaning here. And then with those clean statuses, I will be using a pre-trained field mask model from Hugging Face to infer some hashtags from these posts, and also write an executive summary using a summarization model. Then I will end up with the hashtags list and the summary text, and I will be writing a consolidated report that I will be storing on my data lake as well. All of this is going to be stored in Min.io, as I was saying. So I already have a bucket prepared here, and everything is going to be right there. So now let's have a look at the code itself. So this is how the Kedro project looks like, and it follows the very standard Kedro directory structure. The interesting thing is that the configuration, the data, your notebooks or scripts, the source code or your library code, and the tests are cleanly separated. So from the start, this already encourages you to follow good software engineering practices. The metadata is stored in pyproject.toml. So essentially, any Kedro project is a Python library that you can install, extend, and so on. The important thing is that there are some standard files and directories in the library code. So if you go here, you will see that there's a couple of files, the pipeline registry and the settings. We're going to skip them for now. And most importantly, you have the pipelines here. And we have 3 pipelines. You can see that if you run Kedro registry list, and Kedro already knows that there are 3 pipelines at the moment: the data extraction pipeline, the data cleaning pipeline, and the reporting pipeline as well. There we go. So as I was saying, the data extraction pipeline uses some smart combination of the Mastodon API with Pydantic. So I'm using Pydantic v2 validation capabilities so that I can define how the result of the REST API is going to look like, which is essentially this Pydantic model over here. And then I am transforming the result from the pipeline, the result from the REST API, to a list of Pydantic objects using this validate JSON. And this happens automatically and really fast. And then I'm transforming that to a data frame using the Polars library. If you haven't used Polars, is a data frame library alternative to Pandas that is written in Rust and Python, and it's really fast and nice to use. And since Polars is compatible with Pydantic objects, I'm doing this Polars from dictionaries to this list of objects, and this gives me a nice Polars data frame. But this is a little bit abstract. How does that look in practice? Let's open a notebook for that. So I'm going to create a new notebook called demo. And then, I could go and fetch the data directly, but instead I'm going to leverage Kedro catalog capabilities for that. So if I write load ext kedro.ipython here, this will inject several variables into my notebook that I can use to start using Kedro from the notebook straight away. In particular, if I do catalog.list, you will see that there's a series of datasets already defined. These come from the catalog. We're going to look at that in a moment. And if I do catalog.load and then the clean status is clean, then you will see that this is a polars data frame. Consider this. I didn't say at any moment where the dataset lives or what special options did I have to use to load it. So this allows me to do a very clean separation between the configuration of my input and output and the actual code that is going to make use of that. But then where do those definitions live? Well, as I was mentioning at the beginning, this lives in the catalog file. So if you go here, you will see that this status is clean datasets that has this type over here. So it's a custom Delta dataset that I wrote for the purposes of this demo. The file path is this S3-like path. So it's fetching the social summarizer bucket and the status is clean object inside of that. It's using some credentials that it defines somewhere else. And it has some arguments in the case that I write to these datasets and not only load. So essentially what's happening is that every time I load these datasets, Kedro is fetching this Python class over here. It's passing that file path, and it's using, in this case, polars to load the datasets and give me a nice data frame that I can use. So if you don't even want to opt for the whole Kedro pipelines and so on, just using the catalog can be very powerful for you. But then what happens with the rest of the pipelines? Well, I mentioned that I had a data extraction pipeline that I mentioned. Then there's a simple data cleaning pipeline that performs some filtering and so on. And there's a reporting pipeline as well. So let's have a look at that. My reporting pipeline consists of several nodes. So I'm, on one hand, taking the list of posts that happen to be in the data, and then inferring some hashtags. And the way I'm doing that is by using a fill mask model, and then adding this hashtag sign, and then the mask, which is what the model expects. So basically, I'm using the content of each of the posts and trick the model into thinking that this is a tweet, basically. So this is giving me a possible list of hashtags that will make for a nice match for these posts. And as you can see, there's no I/O happening in this function. So I'm receiving a normal polars data frame, mask filler, which is a Hugging Face pipeline or a p-train model, and then a parameter that tells me the maximum number of statuses that I'm going to use. This is for control purposes. So this function over here has nothing that is special or specific to Kedro, and you can go and reuse that anywhere you want. Same goes with a function that writes an executive summary. So I'm creating a very short prompt, joining all the posts, and then using a summarizer model to create that summary. And then finally, I'm combining both the hashtags and the summary to create a final report in the form of a string. So if these functions are just receiving Python objects, then how do they know what objects do they have to receive? Well, that happens thanks to the pipeline definition. So this pipeline definition is what connects the node functions that I just saw with the datasets that are defined in the catalog and links everything together so that the pipeline runs in the appropriate order. So basically, I have these nodes with the get hashtags function, and this will receive as inputs the status is clean. This will be the data frame variable, the fill mask model. We're going to see its definition in a moment, and then some parameters as well. So let's have a look at these two extra datasets. We already saw what status is clean is, but then notice that I have a catalog only for the models, and I have my fill mask model here. This is using a HF transformer pipeline dataset, which is a new dataset that was introduced in Kedro Datasets 2.0, which was released early this week. I'm specifying what's the task, in this case, a fill mask model, and what is going to be the model name. So this is a model that I found on Hugging Face that was trained with tweets. And the same goes with parameters. So if I go to this parameters reporting, you see this is not a full-fledged data set, but it's more like a dictionary of variables that I can use for any purpose. So in particular, I'm specifying that the maximum number of statuses that I'm going to use is going to be 100. So now I have my data sets, my nodes, my pipeline, and it's the moment to run the pipeline. So to do that, I'm going to do Kedro run pipeline reporting. And this is already going to start all the magic. So as you will see in the standard output in a moment, this is going to start by initializing a Kedro session with the project that I have, and then it's going to load the first data sets of the first node that needs to be executed. So status is clean, the field mask model, and the parameters. These have different types, as you can see here. Then this is running the get hashtags function, and it's proceeding the execution with the rest of the nodes. So now I have my write executive summary. All of this is taking a few seconds because performing inference with the models requires some computational resources. And then finally, the consolidated report was produced. So now the pipeline has finished executing. And if I go to my min.io console and I go to my executive summary.txt, you will see that there's a executive summary version that I just ran a few seconds ago, and you can see what the executive summary is. And if I want to load that, I can see that and see that, well, there were this list of topics that were covered. So gold, IR, whatever that means, probably GitHub and Brexit. And then there's a written summary of what were all the posts that we took into account in the pipeline. Whether or not this is proper English or makes sense is out of the question. But the important thing is that we now have an architecture that we can scale and expand with many more things. There's lots of things that we could be doing now. I would like to try some retrieval augmented generation. For this, we still need to write some integrations with existing vector databases. You can also deploy this pipeline in a Docker container using Kedro Docker and put a REST API in front of that so that it's easier to run and you don't need to run it from the command line. And for this to be a user-grade thing, it would be nice to have a dashboard or a web UI of sorts. But hopefully this will come at some point when I keep progressing in this prototype. And in the meanwhile, I will encourage you to give Kedro a try. And if you have any thoughts, we will be very happy to have you in our community. So thanks a lot for listening and looking forward to meeting you there. Thank you.